Yeah, good morning, everybody. Welcome to the 8th lecture of Introduction to Programming. I'm glad to see so many got back from the autumn break. I hope you had a nice autumn break and it wasn't too stressful finishing the assignment. I can tell you did a much better job this time with coding according to what I told you should be returned. So I think when I run my automatic tests, like almost everybody who handed in already was like above this 3 points just from the coding exercises. So very well done. What are we going to do today? We're going to work with files. I think it's the single most important lecture. Like after now you have this knowledge of Python. Now the question is, what are you going to do with Python in your life? And although you might not become programmers, and although you might not think programming is an important part, I think working with files, like every one of you, is going to have this opportunity where you think, oh, this is this very boring task that I have to do now. And usually it involves doing stuff with files, with Excel files, for example. And hopefully this will make it easier. And hopefully you'll see and think back to your Python knowledge and think, okay, I can make this task, I can do this much quicker. Right. But first of all, let's talk a little bit about your experiences. Then let's talk a bit about the 4th mandatory assignment, which is online since Monday. And the content is going to be some remarks on running Python locally, working with files, and then working with Excel files. So let's start a little bit by talking about your experiences. And, whoops. What I would like you to do, please go to menti.com, use this code 4676. I have 2 questions for you, and then there is more of an open discussion where you can fill things out. Oh, thanks. So the question is about exercises. The exercises help me understand the topic better. To the right, strongly agree. To the left, strongly disagree. And then there is, I want more direct instruction through TAs. That means for now this was very, it's self-driven. It could be that the TAs show you solutions. Yeah. The question is, do you want that? What do you think about this? Yeah, let's take 20 more seconds. Okay, let's have a look. So the exercises help me understand the topic better. I'm glad to see that we are here on the right with in this agree situation. I think it's not as strongly as I would hope it would be. Maybe, so how it's going to work is the next slide is again like a code example where you should have an opinion on what is printed. But then afterwards, there's going to be an open-ended discussion. So I'm going to continue with the lecture and you can write some comments on what you want to see improved there and then we can discuss. But maybe already now. The exercises help me understand the topic better. Are there any things you would like to see improved? Is there anything that comes to mind that you would share publicly? There's going to be an anonymized way of doing it later. But yeah?
I found that some exercises cannot be done by yourself at any cost. Like, no matter if it goes to books or if it goes to the internet, it cannot be done by yourself.
Okay, yeah. So the feedback is that some of the exercises cannot be done by a single person, so it doesn't help to go to the book, you won't find a solution there. It doesn't help you to go to the internet, you won't find a solution there. How many of you share this experience? Yeah, okay, so quite a lot. Does it, the question is now, how do you feel about it? Yeah, does it give you the feeling that you are not on, like, is the feeling that all of the exercises, I mean, that's maybe a general question for you, if you feel about that way, that if you can't a exercise, then you do badly in this course. Is that how you feel? Yeah, I see a lot of nodding. Okay, yeah. So the feeling is, I can't solve exercise 4, I'm behind. I must have done something wrong. Okay. That's just another comment here, and then I'm going to say something about that. Yeah?
I think the worry might be for the written exam, where you cannot use the internet and you cannot rely on your fellow students. So I think the thought here comes from if you can't solve the exercises by yourself.
Right. Okay. So the feedback, yeah. So the feedback is that this is tightly connected to the exam. Yeah, because in the exam you won't have the internet. You won't have your colleagues to help you out, so this is, of course, this seems to be a big problem. Yeah, that, okay, yeah, and I agree. I mean, a comment I would like to do here is that when I plan the exercises, they go up in difficulty. Usually I want that task 1 is something that all of you can solve, yeah, and then task 2 is something where I hope all of you are challenged. Task 3 is often something where I might make a mistake when I thought about the exercise and then I made a solution, and maybe I also made a mistake in my first try. Yeah, because it's kind of difficult and it's kind of involved. Yeah, another?
It's just, I think with exercises it's okay because having them harder,
yeah,
it makes you want to learn. But when it comes to, for example, this assignment,
yes,
we had,
yeah,
it's something you should be able to do by yourself.
Yes.
And it's something, if you cannot do by yourself, such as sitting out, so questioning if I missed something or if there is something I don't understand.
Okay, yeah. That's very nice feedback, thank you. It's, and for the assignment, I want that you discuss it with your colleagues. Yeah, I don't want you to say, I can do it all by myself. And I hope you agree when you look at like who of you here in the room, who took a look at this example exam that is on LearnIt? Yeah, that's actually, it's not that many, maybe only half of the class. So I hope that, and there's going to be end of November, somewhere in end of November, I still have to discuss with the TAs. There's going to be a session where TAs are going to solve this exam review. So there's this example exam here. Yeah, and end of November, there's going to be one session where the TAs are here, and the idea is that you kind of solve it together, and after a certain amount of time, they will always present a solution, and back and forth. Yeah, the hope is that if you see the exam, then that you will think, so passing, just when this is an actual exam, so this was used in a previous course. Yeah, and the passing level was being able to solve the first 4 and then getting at least a little bit of one other. Yeah, that was passing, and then it's basically one more task is for one better grade. Yeah, and they go up in difficulty quite fast. Yeah, so the first are basically these tasks 1 that we have in the assignment all the time. Just tell me, what is Python gonna tell you when you put that one into the into a Jupyter notebook? Yeah, and that is basically here for 3 tasks. Yeah, you can just use Python directly to answer that. Okay, and then there's this 4th. Rewrite the following statement as a function taking 3 parameters, where you should say, I can do that by now. And then there are some more involved questions coming up. Yeah, and then there is something about object orientation. We're going to do this next week. And there's going to be something about files. That is this one. We're going to do this today. And then there's going to be something about algorithms. That's what we do in 2 weeks. Yeah, so it's like the difficulty raises quite rapidly then. Yeah, but first 4 tasks, that was the passing level. You got a 2 for solving those, and maybe writing something with 5.txt. Yeah, okay. You should have a look, because I think it eases how you feel about these assignments. Yeah, the assignments, usually the first task in the assignment is on a very low level, and then they go up. And I don't expect that everyone here can solve all of the exercises. Yeah, what I expect when I put solutions online, that you look at the solution and you find out, like, why does this work? Okay, right. But this is good to know, that you feel that. Oops. Just a second. We were here. That you have this feeling. And I mean, I don't want to make it that easy. I want when you go in the exam and you solved most of the exercises, that you have no problem in the exam. Yeah, that's my goal. Okay, there is gonna be, as I said, like this open discussion where you can put more thoughts here. I want more direct instruction through the TAs, so that's a bit like in the middle. Yeah, and yeah, I mean, first of all, I have to apologize because I tried to work with ITU and they didn't really work with me on finding this additional room for having these like discussion of the most difficult exercise, maybe as a group. I think I definitely need to do something for next year, but the question is, we can also change it for the remaining 5 exercise sessions. So, is there anything you want to share with regard to the more direct instruction? I mean, when I learned programming, it wasn't the TA. In Germany, it's a little bit different, but there was basically the professor was there and just said, this is how you solve exercise 1, this is how you solve exercise 2, this is how you solve exercise 3. This was really not useful for me. Yeah?
I found it very useful in the current assignment where the TA just list a few steps you should take.
Yes.
Problem.
Mm-hmm. Yeah. So that was, I think I told him to that you discuss it like 12:30. That you have this discussion of that's the exercise, those are the tasks, and maybe that's how you can approach it. For the exercise today, I actually put some solution steps in there. Like, this is how you should approach it. I hope this is gonna be helpful. Yeah. Any other suggestions? Here, if you like this more direct instruction is, I mean, it seems very helpful. Yeah, if you're completely lost, then you go there and you just see solutions. But honestly, it's not gonna help you just to see these solutions. Yeah, it's a matter of how the TA is gonna present it to you, if that is helpful or not. Yeah, it's much more helpful banging your head for half an hour against question 1. Yeah, and then seeing a solution with the help of the TAs. I hope there are enough TA. You feel that there is enough TA support. Could I see, like, show of hands? Do you think who thinks there should be more TAs available? Okay, that's like 30%. Okay, I'm very happy that not all of you raised your hand. But this is good to know. There's going to be an evaluation of this course and coming in, I think, 2 weeks, and you should definitely say something about how you feel about the TAs, because if I always tell them I want as many TAs as possible, they tell me, no, you get 2. I tell them, no, can't do it with 2. This year I was very lucky with 6. Yeah, I mean, this is like, I mean, you see it from the other courses that 6 TAs are impressive. But it would be good if you comment in the evaluation on whether do you think this was a good amount or could be less, could be more. Right. Okay, so there's going to be some anonymized discussion board later on. Let's switch topics and let's see. What you forgot over the autumn break. So there is a little program. I'm going to discuss the program. So it's filter greater 0. That's a function. It takes a list, and the idea is it should retrieve all the elements that are greater than 0. And it does this by going, so there is this all greater 0 list here, empty list. It goes through a list, and for every element that is greater than 0, it just appends to this list and returns this list. Okay, so there's list 1. There is list 2 here. I want to know from you what is printed on the screen. Here, so there's a print filter greater 0 list 1. So list 1 is passed in here. It goes through this whole, through this for loop. All the elements greater than 0 are added to all greater 0. It's returned, and it's printed. And printed means you get these funny list brackets here. Right. The same thing happens for list 2. The question is, what's the output? There are 2 print statements, so there are 2 lines are printed. What do you think? Yeah, and we're gonna do it, like, please try it yourself and make a decision. Then we're gonna look at the results. Then you can chat a little bit about these results. Try to convince yourself, why is it, why do you thought this was the right solution? And then we're gonna vote again. Take a look. People are missing. 10 seconds. Results are in. Let's have a look at the results. So we say solution A, then we have 37, then we have 4, then we have 3, then we have 1. Okay, clear majority for B. B being the output of this program is 10, 20, 33. And then the next list is going to be 2 and 3. Okay. Clear majority, still. Take a close look. Again, discuss one more time. I don't know. We're just going to run it, and then we'll see what the output is. Yeah, but discuss it for 2 minutes or so. Vote again. Let's say 1 minute to the vote. Vote, vote, vote. I think there are like 18 people. Maybe much more confused than they were before about their answer. 15 more. Let's say 10 more seconds. Okay. 9 people are super confused and don't know what to answer now. Let's have a look at the initial results. Oh! What happened? Very impressive. 26, 25, 72. Big shift in the opinion what you think was the right answer. I mean, and I have no idea what has happened. I mean, there are 4 people who are saying it's C. The clear majority says it's C. We don't know if it's C. There's nothing. What I would like to know is from a person that switched to C, why? What is, I mean, C looks like a very strange answer. Yeah.
Because it returns the variable.
Yeah.
Then it saves all the values inside.
So there's this all greater 0, and it has,
And you
yeah.
use the function again. So all the values should already be inside, and then you just add the last two.
Right. Yeah. So I hope that's a perfect description of what is going on. So there's this all greater 0. That's a list of values. You call the function, it runs through, it filters out all the negative numbers, returns it. And now all greater 0 has some elements in there. You call it again, filter greater on list 2. You would expect maybe from how I phrased everything, and that's hopefully why you were expecting this B to be the answer, yeah? That you would say, oh, new run of the function, everything starts anew. I put in 2 and 3, I filter out -1 and -1, and that's it. Yeah, the result should be 2, 3, so it should be that one. But as you said, all greater 0 in the second run has some values in there already. Yeah, there are some values in there, and that's 10, 20, 30, and 3. So if you run it again, it's going to filter out -1, then it's going to append 2 to this list, and then it's going to append 3 to the list and filter out -1. So it's true, C is the correct answer here. And I said you did a very good job in assignment with this hand in 3. Yeah, you did great. When there was a problem, that is the problem. Yeah, you defined a function. I told you there are these. No, and I said, oh, it has to work with this call. Yeah, and in my test, it just tries one more time with another list, and then you just reuse the values. So how should it be? And let's start code here to get a bit more accustomed with that as well. What you so if we run this, and I want to say it's also on the slides, some people complained about it's difficult to run code. You can go to extensions, and then you can go to look for a code runner extension. That one over here, and you can install that. It's on the slides. Do it later if you want. And that makes it a bit easier to run code because, oops. Because then you have shortcuts that just allow you. I think here it's Control, Alt, and N. And it's also, you have run code here directly, which makes it a bit easier, okay? But the output, I hope you can see this, is this 10, 20, 30, 3, and then 10, 20, 30, 3, 2, and 3, right? What should we do to get a correct solution? Yeah, like filter out all the elements. Like, what do we have to do to get to solution B? Because that is the intended solution. Yeah.
Instead of putting the list in the local global scope, you put it under defined function.
Right. You make this a local variable. Right. If we then run this code like this, you see this 10, 23, 33, and 2, 3. That was solution B. Okay, and just this was the main problem, I would say, for hand in 3, like this mandatory assignment 3, like defining these variables in the global scope and then using them in this local scope inside the function. Yeah, assuming that it would start fresh again in the next round. Okay. Questions? Yeah, I know, I'm so sorry, it's always tricky. Yeah, but I'm so impressed that you, I mean, I have no idea. Maybe it's just two people thinking it's B, talking to each other and then seeing, maybe it's not B. Yeah, because only 4 people can't spread like this information that C is the correct answer here. Yeah, very nice. Well done. What did I want to say about? I also wanted to say something about this Visual Code editor. It's on what is also on these slides. It's still, I guess, a bit of the question about why do we use this? Why do we use this code? Jupyter Notebooks are so nice. Yeah, and I agree, Jupyter Notebooks are really nice. And for most of your tasks, Jupyter Notebook is maybe the better editor here. What we're gonna do next week is we're gonna talk about testing, and we're gonna write programs that actually like open some kind of graphics window and you do something in this window, and then this is just not possible anymore in Jupyter Notebook. Jupyter Notebook won't know what to do. Yeah, you have to do it in this Visual Studio Code. Visual Studio Code has other advantages. For example, what I really like is that you just hover over something and it tells you what it does. Yeah, you just say, you look, what is L? It doesn't list. Yeah, what is X here? X is an integer. Yeah, and it just infers that by how you use it in the code. And that makes things very, very easy. When you go over print, it's going to tell you how does print work, and it gives you all these additional commands, like there is the separation, there is an end, there's this file, and there's this flush that you can also give it. So that's very nice. What we're going to discuss next time in detail is how do we add this information? Yeah, where does it come from, this append here? It says def append object. Well, it appends the object to the end of the list. Yeah, that is what is written in this documentation. And what we're going to discuss, like why do we do this and how do we do this, but it boils down to writing these comments here. These multi-line comments, you start with 3 double quotation marks, and you just put a comment on what is this function doing here, and the next time you hover over it, filter greater 0, you get retrieve all elements that are greater than 0 automatically. Yeah, we're going to discuss this next week in detail about how to write these commands, because I think this is not a good description of what is going on in this function. You might think it's a good description, but there is more theory to it and more best practices how to write this. Yeah, but this is also something that you can easily do in this Visual Studio Code. Yeah, and that's what it's nice for. And debugging, we're going to talk about that next week as well. Okay, right. Let's go back. 4th mandatory assignment, it's posted on Learn It. We're going to discuss it in detail next Wednesday, because it's going to be about writing files, reading files, and we first have to discuss how do we read a file. Okay, let's see how far we got. The only thing, like when we align this course to the intended learning outcomes, we had this very annoying intended learning outcome, like this bulk of text, analyze a given simple computational task, such as manipulation of a text-based database. Yeah, that's basically what we did for the first 7 weeks. That's basically what we're going to do today, because today is a text-based database, and that's going to be reading from a file or reading from an Excel file. Yeah, what I want to say is this is the most important intended learning outcome that you can program. All of the other things, we're going to discuss test correctness of a piece of code next week. It's going to be like, because you kind of know how to program, and then testing is me telling you, like, this is the approach to testing, and you being able to test already, because that's basically what you did all the time. You wrote your functions, and I hope you tried to test them. And we just make this more theoretical. What does it mean to test code? How do we test code better than maybe what you do ad hoc when you do it right now, by just writing some code and then seeing whether it works? Yeah, there is some more theory. We're going to do this next week. Write program documentation, that's exactly what I did with these 3 quotation marks. We're going to discuss this next week as well. And then there is reason about computational complexity of an algorithm. That's going to come in 2 weeks. Yeah, and the idea is that you basically know what the limitations are and what an algorithm is. And if somebody gives you an algorithm and you should judge, like, oh, is this going to run in my program? Is this going to be fast enough that you can actually make a good statement about this, if it's pretty simple. Okay, and then express functionality in terms of abstract data types. We're going to do object orientation next week, which is going to be very important for, like, then you have things like enterprise systems in, I think, your 3rd semester, and then they talk only about objects. Yeah, and you have this knowledge from Python then. What does it mean to be an object? What does it mean to be a class? And they were going to tell you, okay, and if you are in a large company, then programs are like this. Yeah, but they are object-oriented. And you are able to talk about what is an abstract data type, what is an application program interface. Right, and then there was use text-based tools for program development in Editor. That's basically a Jupyter Notebook or VS Code, command line tools. We're going to do this more frequently from 2 weeks ago. Version control system, I'm going to tell you in the second to last lecture about it, why this is cool and how you can use it, but it's not that all of you have to apply this. Right, but we're still in this very first task, and it's no problem, yeah, because this is the important task that you are able to program. Right, okay, running Python locally, that's what I told you. Let's work a little bit with files, and that's the main content. Okay. Why do we do this? Like, why do we want to use files? Yeah. I hope you agree that your programs so far are a bit boring. Yeah, it's like you have your little Python code, and maybe I give you a list, or maybe I give you this Sherlock Holmes, like in the assignment 3, this little Sherlock Holmes quote. Yeah, and then I tell you, work on this quote. Yeah, so everything is stored within this Python program for now. Yeah, it was always, I gave it to you. This is the data you have to work with, right? And it's always small. It was like the very first paragraph or something of something. And that's, of course, usually what you don't want to do with a Python program, yeah? So what you want to do is often your program does something and you want to save. Like, what did it do? Like I did all this computation. Yeah, now I want to share it. How do you share it? Do you take a screenshot of it and then say, here, those are my results? No, usually you write it to a file and you just share this file with all of your peers, right? Maybe more importantly, you have input that comes from a database, like some gigantic input, and we're gonna work on really large input today. For us, a database is gonna be a file. I'm gonna tell you that's the file, and it might be 100 kilobyte or 600 kilobyte, and then you manipulate this file. In the next semester, you're gonna work with databases. Yeah, also with Python or with a Python perspective there, and that's gonna be a real database. That's like gigabytes of data. And you have to find out how many people lived. Like, what are these 10 people that are of interest to me? Yeah, and then the question is, on the database side, how do I select, how do I find the people that I'm interested in? And then on the Python side, how do I work with this information? How do I produce the output that I want to share? Something that I want to say here, the book is really, really thorough on all of this, reading files, writing files, manipulating something, and it's, in my perspective, really, really bad. Yeah, it's like, it tells you a lot of stuff that I think you don't need, and then when it comes to reading and writing files, it does it in a way that nobody does it. Yeah, it's like if you were to write code like in here, and you were to share this with somebody who has experience with Python, he would tell you no, he or she would tell you no. That's not how you write files, that's dangerous, yeah, because you will forget certain things. Right. So we do it a little bit different, and it's very condensed to the hopefully most important part, how to read a file, how to write to a file. Okay, crash course. I have no idea what you think a file is and what you think a file system is. There are a few things here on the slide, like a file is described by a file name, a file path. Files are stored in a hierarchical way, and then I tell you, like, this is how these lecture slides look like when I open the editor. But I think the main question here is, what do you think a file is? So a file usually, and I hope you all agree, is if you want to look for a file, you go on a macOS, you go to this Finder here. Oh, and let's go over here. You go to this Finder, and I think I have no option to make this larger. Yeah, and it looks horrible. But I hope you agree, files are these thingies here. Yeah, and if you're on a Windows machine, then you have your Explorer. And you can also go through this file system. And navigating through the file system usually looks like this, that you have certain files. Yeah, and you make differences. There is a directory and there is a file. If it's a directory, I can double click on it. And then I open this directory. And there might be other files inside. So if I go to teaching here, then you'll see there are a lot of other teaching related things in here. There's ITU teaching, that's the courses that I gave at ITU. And for example, we are now working on Intro to Programming GBI. Right, okay. So this is like clicking and navigating, and I hope all of you say no problem. I know how to find my files. I know where they are. I can navigate it. I can like click here, new folder, teaching for next semester. No problem whatsoever. Right. But then when it comes to, oops, it was a bit fast. But then when it comes to what does the computer think a file is, that's a little bit different. So this, and you can see it here in this, I think it's best explained here in this view, that you have this kind of hierarchy. Yeah, so you have a folder, and that one has subfolders, right? And then there are files, and that's where there is no more directory. So there is we went along, maybe we went many steps through our Finder, and then we finally located our file, which might be the lecture 7 screencast or something like this, right? If I then click and I say, get me some information, then we see this, and I hope you can see it. Wow, it's really. Up there, that's the file name. And down here, where it says where, this is the path. Okay, and what is meant is to open files, yeah, and to work with files. You always have to know what's the file name and where is it located. Yeah, what's the file? What's the path here? Okay. Right. Okay. And there is always a file path that is kind of given to you, but if you have to use it from Python, you have to speak the operating system language. And the operating system language is a bit different from what you see and what you click on, because that one says that, so for example, when you see this hierarchy down here, it actually translates this to a user's MAAU, documents, teaching, ITU teaching, intro to programming. It almost looks the same. It starts with users here, and then it's /// until there is lecture. And in this lecture directory, you have to work with this file name. Okay, and we'll make sure what that means during live coding. Okay. Do you have any questions about like this navigating and what is a path? What is the file name? Okay, I hope that was boring. There is one differentiation that you hopefully never have to care about because you are lucky and Python takes it away from you. If you are on a Windows machine, then a path looks like, that's the main directory, like the main partition, I think. And then you have these backslashes to separate folders. On a Linux and Mac machine, you have slashes here. And this is a great problem in almost every programming language. Like if you share your program with somebody else and you do the wrong kind of slash, then it will just say, oh, I don't know what I mean. I didn't find this file for you, right? In Python, it shouldn't be a problem. It's just for you to know there is a difference, but Python will internally see, am I running on Windows? Then all the slashes are backslashes for me. Yeah, so that shouldn't be a problem. You will see it during the in-class exercise maybe, if that's a problem for you. Right. So now we have files. Yeah, we have a file path, and then we have the file. What is a file? Yeah, and a file is very boring. Like a file is somewhere on this on our hard disk, and I think here it's like down here. Yeah, on my machine there is a little hard disk, and in there you store, like there is this, on this hard disk you store data. And storing data means you have zeros and ones. There's nothing else. There's never is there an A stored somewhere. It's also only 0 and 1s. And the file system says a file starts there. That's the first 0 or 1 of the file. And it says, and that's where the file ends. Yeah, and then in the middle you have 0s and 1s. The question is, what do you do with these 0s and 1s? And you try to interpret 0s and 1s. So that's how you go from data to information. Like what's the information in your file? And since most of computing technology comes from the US, they were the first ones to give you a way to interpret data. And that is called ASCII. And this is here to the right. And basically it means, it tells you how to interpret what a file is. Yeah, so if your file starts with, let's just make an example, and I hope this works out. Let's say your file starts here, and that is how it looks like. Those are the first 7 bits. That's what we call it. Yeah. So there is a byte, and a byte contains 8 bits. The bits is 0, 1. Right. If you see this, how do we interpret this? You have to look, and that's what your computer does. You have to look into this table. And you see it starts with 1, 0, 0. So I'm here in this column, and then it goes to 0, 1, 0, 1. So we are over here, 0, 1, 0, 1. That's an E. So the first character in my file is an E. That's how it works. Okay, so you have to read, it's a bit tricky to read. So this is the first 3 bits, that's 0, 1, 1. Over here, that says I'm in the 4th column. And then you look in which row am I, and you are in row. In this row, and then you just see what's the cell here. That's an E. That is what Jupyter Notebook is doing, what VS Code is doing, what your favorite text editor is doing all the time. Yeah, it sees all of these bits, it looks into its code table and says, that's an E. Yeah, if you change it with an F, it's 1 down there, For the file, it means, and that might look a bit odd to you now, that the file changes to be this pattern. Right. And that is how it was since, I think that's 1977. That's now 41 years ago. Now UTF-8 becomes more and more predominant, and it's just another way of reading these bits. Yeah, UTF-8 also has a code table, and it just says, and if I think this is a UTF-8 file, this is how I read it. Why do you use UTF-8? Well, if you, I mean, for all the people that don't have English as their native language where they communicate with, you look at this code table and you might say, oh, there's something missing. Like how do we ever write an Ö? Yeah, there's no way of writing an Ö. And then people usually came up with solutions and said an Ö, I don't know how it translates in Danish. Is it OE? Yeah, OE. Yeah, and then there's O with AA and things like this. So they came up with these solutions. Yeah, UTF-8 says, right, and I forgot to open this one here. Yeah, whenever you feel like you have the time. You can also do it after the lecture. I leave this Mentimeter here open. What could be improved? If you want to share something anonymously, and maybe we can discuss it, you can just put it here. Okay, UTF-8. It says, how do I search for this? 6. Okay, my browser thinks Ö, that must be O, you are meaning. Was it somewhere? Where is it? Sorry, I didn't hear. Down, down. Oh, you know your code tables. What? Two. There we go. Yeah. So whenever you see C3698 and C, I think is, yeah. So this is 16. This is going to be actually, is this still? Yeah, this is 16 bits that you need, that you need there. So this is that code over here. No, it's actually D8. You can translate this into bits as well, and that then says it's Ö. Yeah, but if you get the encoding wrong, and your machine thinks it's still on this old style here, it will tell you, I don't know what this is supposed to be. Yeah, and sometimes you might have seen it. I clearly remember it, that sometimes I wrote emails in German, and I got an email back, and all my umlauts were off. Yeah, that's because the other machine thought, that's just old ASCII. Yeah, and I have no idea what he meant with that. Right. Yeah, and in UTF-8 you can, yeah, there's, like for everything, there is a basically symbol for that. Yeah, and it's just another way of encoding. But there is an elephant, so if in your file you see a certain, it's then 1F418. That's the encoding, then that's just an elephant. Yeah, and it's no problem. But like the decoding table is huge. It's not this little square anymore. Like it's a huge table. Okay, but that's how you interpret a file. Like it's all ones and zeros, and somebody looks up what do you mean with these ones and zeros. Right, and sometimes it works, and sometimes it doesn't. So for example, if you take your text editor and you load the exercise for today, this Python notebook, the text editor is going to say that looks like this. Here. Yeah, and it's difficult to read for us, but it's very easy to read for a Jupyter Notebook. Yeah, a Jupyter Notebook then just knows what to do here. If you look at these lecture slides and you just open them in a text editor, it makes no sense at all. Yeah, because that is not to be meant for a human to be read. Lecture 8 is meant for PowerPoint to be read. And PowerPoint knows how to interpret these zeros and ones. Yeah, but it's not that we could make sense out of that. Okay? Yeah. But still, like what I show you here, that's when I open it in text editor. And I say, let's assume this is some certain encoding, like this ASCII encoding, and then it will tell you, yeah, that's how the file looks. Yeah, and there is no meaning to it. So there are these two worlds, and these two worlds also make it either easy to work with the file. So this here is easy because you can read it, and that's also, you can load it into, it's gonna mean you can load it into Python and work with that. This is difficult. Yeah, to work with PowerPoint files in Python, probably not possible. Maybe there's a package where it's explicitly stated this is how you work with a PowerPoint file. Okay, any kind of question with regard to these files and encodings? Okay, then the last thing before we actually read a file is gonna be absolute versus relative paths, and you just have to know that when you specify something. I'm gonna use a terminal now, like that one. Okay, and at some point we go a bit more into detail here, but in a terminal basically you get a bit nicer access to certain functionality on your computer, and it makes it also possible to see a little bit better how to load things into Python, because that's how you can check it in the terminal. So we can cd, that means we change the directory, and that's basically what I clicked on, but now I can also say I want to go to Documents, Teaching, ITU Teaching, Intro to Programming, and then Lectures. And with ls, I can list all the files. So basically, that is what the Finder is telling us. And I think I want to go to one more test examples. Here we are. So this is going to be the live coding notebook. Those are going to be two files that we are going to work with. Okay. And the last thing that we need to know, so how do we tell Python where the file is located? Yeah. The easiest way is you just store all the files with your Python file or with your Jupyter Notebook. You store it in the very same directory. There's nothing to do for you. Yeah, because you just have to provide the file name. You don't have to say anything about the path. Maybe that's the solution you want to go for. What is it if I want to run a Python file in here? Like my Jupyter Notebook is in here. So everything is gonna be in relation to this Jupyter Notebook where it's located. But what is it if I want to, for example, open secret password file? Secret password file is one level up. Yeah, so there is, just to also give you this intuition for it, so there is text examples, no. Teaching, ITU Teaching, Intro to Programming, Lecture. So what we did on the terminal, we navigated to this directory here. And now we want to open a file that is one level up. Let's say we want to access this file. Where was it? Secret password file? Over there. Yeah. How do we do this? And that's the only thing that I want to discuss here. It's by adding something called a relative file name. So if you are somewhere and you want to access one level up, all you do is, and I'm just going to list like the file, you do 2 dots. 2 dots means go one level up. Yeah. If I want, and then I can see there's the secret password file, and its path is 2 dots, and then the file name. Yeah, that's how you go one level up. If you were in the lecture directory, but you want to access, for example, this overview.txt, which is here, then you would have to say, okay, there is text examples overview.txt, like this. Then you go down. Yeah, going up, 2 dots, going down, no dots, directory name. Okay, it makes much more sense when we read files in Python. Okay, this is what's on this slide. Yeah, so there is these absolute paths, that's those you know, and there are these relative paths. And here's an example also for, you are in this directory bacon, you want to access spam.txt. this spam.txt over here, so that one is spam.txt. Like in this fizz, it's fizz spam.txt. That one out here is dot spam.txt. Okay. The easiest solution is you just put your Python files wherever the files are you're working with. Yeah, but just keep that in mind and look it up. Yeah, if you're unsure. Right. Okay. Let's read a file and then take a break. So there is an overview.txt, and that is on Learnit. Yeah, and there are two options to read a file. You read it line by line, or you read the entire file. And working with files means you open it, you work on it, and you close it. And this book here does open, work on it, close. The problem is you always forget to close. Yeah, because it's like you don't really need it in your Python program. But at some point, your operating system is really hate you. It's really going to hate you. Because it's really difficult. Like reading a file is something difficult for the operating system. It's something very easy from Python. But for the operating system, it's difficult. And if you say, I want to read this file, then it means the operating system has to keep track of this file. So it has to have this handler. And if you always forget to close files, there is going to be a large line of open files. And everything will slow down. Or at some point, the operating system is going to tell you, no, I don't open this file for you now. Yeah, there are just too many open files. Please close them. The thing is, in Python, you don't really have to care if you just use the right way of opening. And the right way of opening is with open file name as file. That's all you need to write. Okay, let's do this. So there is, on Learnit, you have an overview.txt, and the overview.txt is a very boring file. It's, if we look at it, it's just, and maybe let's look at it in a text, some more text editor-like thing. It's this file. Yeah, there are names and there are some numbers. We don't know what they mean, but that's overview.txt. Okay, how do we load this file? We first have to locate our Jupyter notebook. It's over here. And this is the Jupyter notebook that lives in the same directory as open, as this overview.txt. So all I write is with open overview.txt as file. And then you do something with this file. And the easiest thing you can do is you read the entire file into a string. You say s, or you say content equals file.read. Okay? You see it didn't complain. That's nice. So it knew what to do. Let's print the content. That's the content of the file. And that's also the general recipe here. Yeah? You load a file by transforming the file content into a string. Okay? There are other ways of doing it. Or maybe is there a question? Yeah. So this is now something. So this is just a string with all of these new lines that make it possible to have a look like this. Another way of doing this is you do it. You say content equals file.readLines, and then let's print what the content would look like after that. And you can see there is a bit of a difference here. So the first one is just the raw string. Like that was exactly overview.txt. If you use this read lines, you see every single line in our, let's make this a bit bigger. Every single line is transformed into one element of a list. Like it generates a list, and all of these strings, they are split apart, or all of the lines, they are split apart. Okay, yeah? Oh, okay. So when I use Jupyter Notebook, I do it now locally. I hope you do so too. There is, I mean, when you open Jupyter Notebook in general in your tree, yeah, then you get this overview. No? The local ones. Okay. Okay, no local notebook yet? Yeah. Do you use VS Code? No. But I mean, no. But I mean, please make sure. I mean, that was like the goal of the last lecture. Yeah. Please make sure that you can type Jupyter Notebook here to start a Jupyter Notebook server, and it requires you to install. We discussed it using this Anaconda. You remember? I hope you do. Yeah. After installing Anaconda, all you need to do is on a Mac, you open a terminal and you type in Jupyter Notebook. On Windows, you even have a button, I think, for that. Yes? So you mean, or what exactly do you mean? You want to open a file from a, like, do you want to start Jupyter Notebook now, or is Jupyter Notebook running? Yes. Yes. So if you use something else, like a PyCharm, then you work with files. Like I can do this in the, if I were to do the same thing now in VS Code. So I want to say with open overview.txt as file. Content equals file.read, for example. Print content. Yeah. Here it's first the question, where do you save the file? Like both in PyCharm and in VS Code, you always have to save a file. So this file is somewhere locally on your machine. Yeah, so I can say, for example, I can put it into Introduction to Programming, lecture, text examples, read file.py. Yeah, so then this file is in the very same directory now. Oh, what did it complain about? Is there a... Oh, there we go. Like this. Okay, and now I can just run it. And it says file not found. What? But you would make sure to either, I mean, you would make sure that the Python file and the text file that you want to load are exactly in the same directory. Yeah. Here it says no such file. Found overview.txt. Oh. Let's just have a look where we are. And let's do this in, sorry for all the switching here. Where's our read file dot? It's there. What? Yeah, I mean, in general, like you can always put, I mean, you can always put the whole path in there. Oh, and now I have a strange feeling here with this code runner that I recommended. Let's see if this, so this is really the, this is now the whole path to this one file. You can always specify that one, and there will be no problems. But it's also, as you can see, very inconvenient because it's so much. Right, okay, and then it works. Okay, I don't like that. I think it's, yeah. That's really annoying with VS Code. Because it always starts, it thinks it's in the home directory at the moment. Yeah, and you have to specify everything starting from the home directory to load a file. That's a bit annoying. Yeah. Any problems with regard to the Jupyter Notebook? Okay, yeah, but it's like just make sure that you can run it locally. And then it's just you navigate to the right directory and you say new. Yep. Yes? There we go. Okay, and then I can, okay, so just it was just confused about not knowing where it is. Now I can say overview.txt here. Yes, I can. Nice suggestion. Is there any other problem? Okay, we are in need of a break, I think, but just to finish reading a file off, and then we are gonna start with a little exercise right after. So there's one more thing to read a file. So there is. Now it goes on off. And that is usually how I do it. So there's open overview.txt as file, content equals file, no. And you want to do it something on a line-by-line basis. Yeah, with read lines, you get individual lines. Often you want to do something on a line-by-line basis, and then you write for line in file, for example, print line. Yeah, and that gives you, in each iteration of this for loop, gives you this new next line. When I run this, you see I get Marie 7, Sarah 15, and so on. And you might also see you have these new lines in here, like these operations here. They were also there, and you can strip them away if you want. Then the output looks like this. Okay. But this is all what is to file reading. Yeah, you say with open file name as file, and then you have three options: read lines, or you work like this. Yeah, you go through them through these lines, line by line. Okay. Any questions? Yeah, welcome back. We're still there were a few questions that I'd just shortly like to comment on. And first of all, I think the most important question, that is the most important one for you, is what do I need to use for the exam? Yeah, when I go to the exam, what program do I have to use? The answer is use whatever you want. Yeah, but there is a certain submission format, and we are gonna train this through the exercises. Yeah, and also the final hand-in will use this. You don't upload a Jupyter Notebook yet, but you'll upload 3 files, exactly like it is in the example exam. Right? Because what you're gonna get in the exam is you get a file name, and you get the information. The name of the file must be the name of the question. So whatever your solution is, this one has to be 1.txt. That's where it has to. That's the name of the file. The next one has to be 2.txt. The next one 3.txt. Then 4.py, because this is actually a Python program that you need to write. 5.txt is again an answer to a question, so it's in a txt file. You don't need to use this. Yeah, we should refer to this, the black one. You don't need to use the black one for all of these things. You can just go to Jupyter Notebook, and you have these files locally on your machine, and you say, oh, the answer to a question so-and-so is this piece of code. I just copy it, and I put it into a text file and call this text file as required. This is as fine as using the black one. The black one gives you this idea, I mean, you can work on this file. And with the Jupyter Notebook, you can't really work on the file directly. Yeah. So there you have to trust, you copy it out into this Python file. For example, if it's called, if you're required to have 4.py, yeah, and then that's, and then you have to trust that this cell of your Jupyter Notebook is the answer to 4.py, yeah. And you can check again. You can open 4.py then in the black one in VS Code and run this. Yeah, but it's not required. I saw many students that at the end I mean, when this course was given before, many people used Jupyter Notebook for the exam, and that works just as fine. I think sometimes solutions were slightly off because they copy and pasted wrong and didn't check. Okay, just to clarify that. Then, and then there was another good question about what is actually happening here. Like with open as file, content file.readlines or file.read or for line in file. Yeah. So what you have is you already have you always have the file on your machine. Yeah, it's called overview.txt. It's over here. Overview.txt. Yeah. And then what you do is you say open. I want to open this file. And the most important part here is this. As file. That's a variable. I can call this G, and I have to say G.readlines, and it's going to work the same. So you say from Python, whenever I mean this file, I will from now on call it file, which is like the default name or F, but you can name it however you want. Yeah. This then refers to this file. Yeah. But it doesn't do anything on defining it. Yeah, it just says whenever I'm going to talk about overview.txt, I'm going to say, I'm going to use this variable file from now on. And then you have certain options, what you can do with a file. For example, you can read. And if you call file.read, what is going to happen is that Python is going to read line by line and put everything into the variable that you put to the left. Yeah. So here, content. Content is not, I mean, maybe it's a good name for what is in here, but it's again completely arbitrary. You can say ABC, print ABC, everything is still going to be fine. It's just whenever you talk about this string or this list of lines, you're going to use the variable name ABC. Yeah, so this is like with file.read, you read the file into a variable. And this variable should of course have a good name, but content is just, I think, a good name for the content of a file. But it doesn't have to be content. It can be anything you want. Okay? Yeah. So this is, it's also very special notation, and in the book they don't use it. They say you say open and you say close. Yeah, but it's really difficult, or it's really dangerous to say open because you always forget the close. Yeah, and this is not difficult for us, but it's really difficult for our machines. Yeah, if we don't say close. Right, because here what happens if after we call read lines and this block here is gone, then it says close automatically. Yeah, because you can't. So if I want to say something here like print G, it will. Well, okay, there's still this IO wrapper, but if I say read, it's going to say IO operation on a closed file because it has been closed before. Right. Okay. There are these in-class exercises. I'm sorry, we won't have the time for that. Please look at them if you want at home. The next thing what we want to do, and it's equally easy, it's writing files. How do we write to a file? So I have this overview.txt over here. Yeah, I want to add something to it. That's very natural that you want to do something like this. And the way you do it is you do it exactly in the same way. You open the file, then you write to it, and then you close it. And what you, for example, can do is with open overview.txt. Yeah, and then you need to specify something. If you just say open, it's going to assume you only want to read to this file. Yeah, you never want to write. So there are two choices that you have. They're on the slides. I'm just going to tell you here. You can say W for I want to write to this file. Or you can say A. And that means you want to append to the file. Let's first use this append mode. So we open the file with this append statement, again as file. And then we can just say file.write, and let's add some new names, Martin and 15. Right? And then what we have to do is that we actually have to provide a new line. So we want to say, and now the line should break. Yeah, it should be like every single element that we write here, there should be a new line like this. And then it's Jeppe, 27. Okay, I'm gonna execute the code, I'm gonna run. You see no complaints, but also no output, because what should have happened is that overview.txt is now different. And let's just open that one again, I think. Oh, okay, I think I have to close it properly. And open it again, overview.txt, right, okay. And what you hopefully see, and it's a bit annoying here, because when I created this file, there was no new line there. I added Martin and Jeppe to the end, okay. If I do this again, if I execute the very same piece of code again, it's gonna have the very same effect, that it's adding Martin and Jeppe to it. So let's have a look at it again. Right, and now we have Martin and Jeppe twice. Okay, because I executed it twice. This is append, yeah? But the only thing that you want to do is you open your file and you call write down this string. And what you have to always provide is a string. Yeah, you can't put a list there, you can't put anything else than a string. It's like with a print statement. It has to be something human, we can read as humans as well. Okay? What does this W mean? W is usually the mode you want to work in, but write means overriding. Yeah, so when let's have a look at this file again. So it looks like this, overview.txt. I'm just changed the A to a W here. And what is going to happen is I ran it. Let's have a look at it. Overview.txt. And now it's only Martin and Jeppe. Yeah, because the W write actually means overwrite the file. Yeah, whatever was in there before, I don't care about it. I create a new file with just this content. Okay. That is basically reading and writing from a file. Yeah, so you can read with this with open as file. You can write with open, and then you have to provide a W or an A here. And then you call file.write to write down what you actually mean. Okay. Let's maybe go back and actually do some work with this file. So for this, I'm going back to this version here. Overview. .txt. Okay, so now we have our old file. And let's just do one very simple task on it. Yeah. For example, what we want to compute, let's say those are test scores here. 7, 15, 8, 20, 11. And all we want to do is what was the average score achieved by maybe students here in this file. Okay? And on the slides there is a more elaborate example where it also says who did best and who did worse. But let's just say we want to compute the average number. Do you have any suggestions on how to do that? What do we do? What would you do to compute the average of all of these numbers? Yeah, you open the file, but what do you do with the file? Yeah.
So we would read the file by line.
I would also say, let's read the file by line.
Perhaps split by space.
Split by space to separate Marie.
Every other element could be one way of doing it.
Yes.
Should be a number.
Yes. This one should be a number. What do we do with these numbers?
Well, we add them together
Mm-hmm.
and divide by the amount of numbers.
We saw. Right. Okay. So his suggestion is to do it as follows. We say with open overview.txt. Now we want to read. We don't have to say anything here as file. We do it like this. We go line by line for line in file. The following. And then the suggestion is, if we look at these, let me just remove that. If we look here, we see a line as a name, then there is a blank, a white space, and then there is a number. Okay, so the suggestion here is to first split by white space. Okay, so this, let's call it L, line.split. And let's just look what we are doing here. Yeah, so we split a line, and then let's just look what L, like the splitted input, looks like. It looks like this. So we split by space, and to the left we see all the names, and to the right we see all the numbers. Yeah, so we just split it up. What we are interested in is this part here. Yeah, if we want to compute this average, we are interested in this part. Now we have to remember, if we have a list like that, how do we access? Well, this is the 0th element, this is the first element. So we can actually say line.split, we're interested in the very first element. Here. We do this, then we get 7, 15, 8, 20, 11. Okay, let's just move it, let it be an integer. Let's say that this is a number. So far, so good. And then his suggestion as well. Now to compute the average, what we have to do is we have to sum up all of these numbers, and we have to keep in mind how many numbers did we see. And I would say let's make it very simple. So there is a sum of numbers that is 0 in the beginning, and there is a number of elements. Let's also say this is 0. Whenever we see such a line, we want to say sum of numbers equals sum of numbers plus our L here, this new element, and number of elements is always number of elements plus 1. Now I see why you're confused by L and 1. Value plus value. Number of elements plus 1. Yeah. So for each line, we saw one more element there, and the sum of all the numbers goes up by value. Okay. And at the very end, we want to print the average. Print average of average test score is, and then we just say string sum of numbers divided by number of elements. Okay. And it says average test score 12.2, and I think that was also what I did earlier. Okay, but this is more elaborate example. This is usually how you work with files. Yeah, just to tell you, this is how you do it. Yeah, if you want to run some statistics, or you want to collect some more data and do something with this data, you go through it line by line. You select what is interesting to you. So select the test score. That's basically what is happening here. So you split by space, and it's usually you know how elements are split up. Here it was by space. It might be by a comma, it might be by a semicolon. And then you do some work. Sometimes immediately, sometimes afterwards. Okay. Any questions with regard to this example? Okay. There are two more things to discuss, and one thing is so two small things. One is working with an Excel file, and the other one is working with exceptions. I'm gonna start with working with exceptions, just to give you an idea of what it means. It's not gonna be, you don't have to use this often, but it's very helpful if you write good code. So what we saw, but only if there are no questions. It's fine? I hope it's fine. I hope you understand what's going on with this piece of code. You're going to practice this in the exercise. So all of the 3 exercise questions are read the file, and it's always going to look like this. So take a close look. I'm going to upload that and learn it immediately afterwards. Okay. Let's do exceptions. Exceptions are really powerful, and you use them when you have a Python program and you don't really know if it's gonna work or if it's not gonna work. So let's say I ask a user input equals input, which file shall I load? Okay, and then I would say with open user input as file content equals. Let's just do the naive one, reading everything, print content. Something like this. This might happen. You ask your user, which file do you want me to work on? Yeah, you open it, you do some work. Here some work is just reading it, and then you print this content. Okay, I hope the problem is clear, and I hope you agree this is useful. Yeah, you do it all the time. Yeah, when you click on open in your favorite tools, you do something like this all the time. So let's do this. Let's just run it. Which file shall I load? Of course, I'm interested in overview.txt. It's the most important file in my life. Perfect. Yeah, everything worked nicely. Okay, let's give it one more try. Which file shall I load? Not existent. Or txt. Yeah. This file doesn't exist, and my program crashes. It says file not found error, and it gives even more. Meaning to it. It says file not found error, no such file or directory. And whenever you have an error, and we have seen many of these errors, but it's important in programming to sometimes decide this is an error that just, it happens to be there. My program needs to crash. There's nothing to do now. Right. The other side could be you want to write your robust program. It shouldn't crash. Yeah, it should do something sensible when something like this happens. And what you do in this case is you use something that is called try, which is try. Yeah, try to run this. Please Python, please try to run this. And then you say accept. Yeah. If it didn't work, what you just tried, then go to this accept line and print out some code. For example, I couldn't find plus user input. Yeah. But maybe you want to do something sensible here. You want to say, for example, I am loading a default dataset for you, and then you would say content equals default, for example. Oops. Like this. Let's move this print down there. Like that. Oops. I hope you see what's going on, or I hope you agree that it's kind of natural to read. Like, try the following code block. And the semantics are like how it should be interpreted is, try to run this code block. If there is an error, stop and do that thing. Yeah, but don't crash. Yeah, just do the other thing in this case. So let's try it again. Which file shall I load? Let's say I want to load overview.txt. And again, this works. Let's run it again, and not existent.txt. And it's not going to crash this time. It's going to tell you, I couldn't find not existent.txt. I'm loading a default data set for you. And now the content, I mean, in this case, it's a bit stupid. It just says default to make clear the content is now a default message. But you can provide something sensible, something that makes your program not crash, but behave in some way. Yeah, and you don't tell the user, look at this gigantic piece of error message that you can't change maybe anyways because you're not a programmer. Okay? So it's try, accept, and a default message. Right. The problem is a little bit that, and that's, you can save against a lot doing these things. Yeah? You can, for example, say try, my variable a should be 3 plus this list a, b, and c. Yeah? Or just like something nonsensical. Yeah, it's going to tell you, Python tells you this makes no sense. Yeah. Well, you can't write this because you can't use int and list and add them together with a plus. That's something that we discussed earlier. That makes no sense. You can multiply a list with a number, but you can't add something to a list like that. Okay, and now the crucial thing is try and accept. I mean, it reacts to errors. Yeah. So you can write something like this and says everything is fine. Although there was a clear Python problem in here. Yeah, I mean, this line here doesn't make sense. Whoever programmed this did a really bad job. Still, with doing this try and accept, you say, everything is fine. Yeah, no problem whatsoever. So for example, up here, when you load a file, yeah, and after that try statement here, there's something nonsensical going on, and it crashes because of that. People wouldn't know. Yeah. So if I say, for example, up here a equals 3 plus a, something that doesn't work, and I run this code, which file shall I load? Overview.txt. We've seen overview.txt a lot of times now. This file exists. Yeah, but the error message is going to be, oh, I couldn't find overview.txt. I'm loading a default data set for you. Yeah, because this accepts all kind of errors. Yeah, the file not found exception that we wanted to work on is as important as this type error that we wrote down here. Yeah, so the message here is try and accept. I mean, you really have to be careful what you put there. And the other message is you never just write try and accept. You always specify the error that you want to accept. Yeah, down here. Okay. And that works by, you look at what is the error that is the problem. Oops. You look at the error. It looked like this. You look at the error. It's the file not found error. And what you then can do is you can say, I only want to go through this path when this is the problem. Yeah, when the file is not there really. So this means file not found error. Which file shall I load? I want to load this one over here. And it says I couldn't find that one. I'm loading a default data set for you. If I now start in doing stupid things like that, yeah, which is a type error, which is another kind of error that happens in Python. Yeah. Okay. And I mean, the first error here was the file not found error. I want overview.txt. Then it still crashes because of the stupid type error down here. Yeah. So you always want to accept. You you always want to accept on the exact error that is provided. You don't want to accept everything, because then your program is not going to crash, but it's also not going to do something sensible. Okay, so that's the basic message here. Right. I know that was a bit short. What do you think about these try except? Do you have any comments, questions about what you can do? Yeah, that was a bit now Blackboard style. So this is how it works. Yeah.
Could you have multiple excepts? So if it's one type of error, it will have one message. And
Yeah.
it's another error, it will print another message.
As always. This is a good question. In all of my software development life, in Java you usually do these things. You usually catch different errors and have different behavior. I've never seen it in Python code, but that's usually because Python programmers are not like this, the software development programmers. Let's see. We need to include a type error again. 3 plus a list. That makes no sense to Python. And so let's run again and give it a file that is okay. Yes. Okay. You can actually do that. Yeah, you can just expect, and do different things on different errors. Yeah, so here it catched the type error down here. It said type error. It still continued. I mean, it read this successfully. It came to this place. Yeah, it read it successfully. So this still makes sense. Okay. Haven't seen that so often, right? But it's. Any other questions? Yeah. You put it around code where you're unsure. I mean, you never ever put it into code that should behave exactly as it should. No? I mean, that was kind of tautological. You always put it in code where you are having some kind of user input. Let's say you ask the user specifically, like we did here, or you read from a file and then do something with the file content. Because you have no control over this file, you can't be sure if everything is going to work. And only in these cases you use this try and except. Okay. Yeah. I'm sorry. We're starting a bit late, and then it's then I'm always hurrying up here. Right. So reading, writing a file, exceptions. Yeah. What I wanted to tell you, and that's basically going to be almost the last message here. You might run into problems. You might say open file, and it will gonna tell you Unicode encode error. And that is because Python says, it's again this problem down here, Python assumes this is the encoding, but you actually had something in Danish there and you had an Ö on E. If on some of your machines, yeah, you will get this problem that it can't encode this character in position ordinal not in range. That is exactly I found something that is not in this code book that I provided, right? A good thing is you won't see this in VS Code, because VS Code makes sure to set in the beginning the Python IO encoding to UTF-8. And for those of you that don't use VS Code and you run, first you have to run in this problem. It could be that on your machine everything is fine. Yeah, and you read your files just as without any kind of problems. Otherwise, if you run into this problem, you need to put in this tiny little line here in your terminal. You just hit enter, and then it's going to work. VS Code is going to do it for you. I'm not sure about Jupyter Notebooks. For me, Jupyter Notebook works. Right, so this can be a problem if it's confused about the actual code page. Another problem, if you write from a macOS computer a file and you send it to your friend on a Windows machine and he opens that in Notepad, you might see that the line breaks are wrong. Yeah, you'll see a file and this person shows you the file on his computer and it says, oh, everything is line by line, perfect, and you open it in Notepad and you see one large line. Yeah. And that's a problem of Windows. I'm very sorry for that. It's like Windows and Mac OS. Like there's a certain standard, this \n. That's a certain standard, that this is a new line, I told you. Windows wants it to be like this. And what Python is going to do, if you run it on a Windows machine, this is what it writes. Yeah, although you just say this, it's going to write this automatically for you, because this is the problem. But if you write a file on a macOS computer, you send it to your friend on Windows, that's not going to happen, because on the macOS computer, it didn't replace. Yeah. And on the Windows computer, it will say, I kind of list that here as one large line. Just, if you see it, don't be confused. In your Python program, everything is going to work. It's just your notepad will tell you this is one big line, which is a lie. Yeah, it's many, many lines, probably. Okay, right. Exceptions, that was the words I told you. There's working with Excel sheets. Yeah, we shouldn't start to work with Excel sheets now. And what I'm going to do is I'm going to do a little web lecture. I think working with Excel sheets are quite nice, and I think I need only 10 minutes to explain what's going on. Yeah, and how you can work with an Excel sheet. Like how you can access, how you can open Excel sheets, and how you can answer simple questions. Yeah. But what I want to do, and it's not important for the exercises, is that I provide this web lecture. It's going to be 10 minutes, and you can look at it if you want, or you just use the slides to look that up. I hope that's okay. If there are questions, then just post them on this talk platform, or we talk about it in the beginning of next week. Right, so that was what I wanted to say there. But summary, we work with files. You open it, you make Python variables that store the data, and you work on this data in Python. Yeah, and sometimes you need to write back to a file. Right, any kind of questions when it comes to this? Okay, then thanks for today. Have fun in the exercises. See you next week.